Okay, I haven't made a video for this course in a while. Grade 11 Finance, 3U. We're looking at the compound interest part of the course. So we have compound interest, um, we have annuities, we have present value of both. So let's take a look. First, this video is day 1. It's a 3-day mini unit here, and we're going to look at compound interest. So compound interest is different than simple interest. Simple interest, which we won't cover in this class, is if I give you 600 bucks and I charge you 10% simple interest. After 1 year, you owe me 60 bucks, and then the next year you owe me another 60 bucks, and the next year you owe me another 60 bucks in interest. Okay. The difference between that and compound interest is compound interest, you earn interest on your interest. So 60 bucks is added on to this, so 660 here. And then the next year, I get 10% of this as interest. So if you don't pay me anything back and you owe me 660 bucks, 10% of this is 66 bucks. So I add that on, I get, what is that, 726, and then keep going and going and going. Compound interest can make you incredibly wealthy if you use it properly in your investments, and incredibly poor if you owe it on credit cards and different types of credit. So interest on interest is the root and cause of wealth and not wealth. How's that? Pretty deep. Okay. Anyway, let's look at compound interest. What we have here is APIN. Those are your common compound interest questions. Don't think of it as PAIN, pain. That'd just be the wrong thing to do. What we have here is, this is what I like to call the amount, which is the money later. P, kind of PV, present value, present, right? Money now. Money later, interest is as a decimal. We refer to interest per annum, but you'll see in a second that you might need to modify your I. So when you see a question and it talks about 3% interest or 5.5% interest, we always refer to interest per year, even if the loan isn't for a year, or if it's longer than a year or shorter than a year. When we want to talk about interest, we always want to keep it in the same tense, I guess, in per annum or per year. That way we can talk about, we can compare them. Okay, so 5.5 interest per year. So imagine this: if we had 2.6% interest per bi-weekly versus 2.9% interest monthly, that sort of thing is a little difficult to compare. Okay, so that's why we do that. This one here is the compounding period. So this is time. So this is compounding periods here. The equation for A, if we're looking for A, it is equal to P 1 plus I all to the power of N. And then if we want to get P, two different ways to look at this. I used to do it this way. P is equal to A 1 plus I to the negative N, or this is the one you'll see in your text, A over 1 plus I to the N. Either way. It's the same thing, okay? Negative n, remember, as a exponent, and negative exponent means flip. So we would put that at the bottom of the fraction. Okay, so first question here, non-compounding question here. Dane has 2,000 bucks. He 10 years at 5.5% interest. So what I do every time is this: APIN. Write down those, because later on you might not know which question you're looking for here. Is it A? Is it P? Is it? We don't do I or N in this class, not in the short version of the course. But here, let's look at this here. I put $2,000, or Dane puts the money in now. So it's now, so it goes here. 2,000. 5.5%, 0.055. So 5.5 is change is 5.5%. Move the decimal over once, twice, 0.055, and it says 10 years. Per annum, so there's no modifying at all. It'll make more sense in a bit. And then you go A is equal to P 1 plus I to the N. Throw this in a calculator. P, 2,000, 1.055 to the 10. Throw that in a calculator, and you get 3,416 and 29 cents. Next question is, how much interest does he earn? Well, he put $2,000 in, and there's $1,416.29 extra, and that's interest earned. Okay, so there's that question for you. I'm going to jump around. We'll look at this question here. Semi-annually. So you have your modifiers. So modifiers, when you look at the modifiers, what you're going to do is you're going to have to take a look at anything that ends in ly is a modifier. So instead of compounding once per year, you make compound twice per year, and that's called semi-annually. So semi-annually, semi-an is 2. What else do we have? Monthly. What's monthly? How many months in a year? 12. We have weekly. which is 52. We don't do much of this in this class. Bi-weekly, which is 26. That's probably the way most things are going to be done in your lifetime. Every 2 weeks, you get paid every 2 weeks. You get your investments can grow every 2 weeks and that sort of thing. So bi-weekly is becoming very popular. You could also do daily, 365 as a modifier. So let's just see what's going on here. What does this mean? APIN. I'm just going to cut this a bit short. So my interest is this. Okay. And she's putting that money in now. So that's present. And the question is, what is it later? And it says 7 years. Now, here's the deal. You got to figure out the modifier. Semi-annually means twice a year. So what you do every single time with the modifier is you're going to divide interest and you're going to multiply term by the modifier. So what does that mean? Well, if she's earning 6.5% per year, that was 6.5% per year, she's earning half. She earns interest now semi-annually, which is twice as often. So this is 1 year. She'll earn it 6 months in, and then again, and then every 6 months. Okay, so this was before per year, but now it's every 6 months. Now that's great. It sounds amazing, and you go, oh, I earn 6.5% per 6 months. Well, that's not quite true. What you do is you earn half of this, which is 3.25 per 6 month period. But you'll see, even though that seems like half, you'll see that the more often it compounds, the quicker you get interest on the interest, the bigger the number gets. So if we were to compare 6.5% annually versus 3.25% semi-annually, this will get bigger. And then if we, this will be a bigger amount. Okay. So how do you do this? You divide this by 2 and you multiply by this by 2. Every question we'll do in this course will have the same modifier for both interest and payment period. Okay. Otherwise, things do get a little confusing. Okay, so this is 0.065 divided by 2 times 2. That's 14. That's what I say. That's that. Okay, and then you throw that into the equation and get your answer. Okay, let's keep going. Here's a different question right here, and this will be the last one I'll do because they're all the same after this. Compounded monthly. So what principal should you invest today? So just, I mean, this question. Okay, I'm not gonna, later on, you're not gonna know if I'm looking for A or if I'm looking for P. So let's look at this. Let's take a quick break for a second. My question's over 6 years, so I know this is 6 to start off with. My interest is 5%, so I know this is 0.05. Okay, it's monthly, so this is divided by 12. Okay, and now one thing I'm gonna look at here is 5 divided by 12 is not a nice whole number. Okay, so if you want to take this to 4 decimals, you can. So you can figure out what this is to 4 decimals and use that. It's not exact, but then again, 52 weeks aren't exactly in a year anyway, right? So, 12 months. Well, 12 months are in a year, but you don't do things by month usually. Okay, so our assumption, just quick, our assumption is that every month you earn the same amount. But the truth is, you're not going to earn the same amount in February as you are in January. Okay, so a little bit of rounding is not bad because these are the exact answers that you're going to get or use in a bank. That's right. Okay, anyway, so back to this. Where is this 10,000? Is it A or is it P? So the question is, what should be invested today? So this is now. So I don't know what should be invested today. This is $10,000 in 6 years. So here's a fair question. Not the best question. Tomorrow's question will be better. The next lesson's question will be better. This is, I have a chunk of money. How much money should I put away now? Okay, so I can have $10,000 later. You're not investing on a regular basis. It's just I have a big chunk of money. I don't know where I got it from. Someone left it to me. I found it under a tree, or I wanted a scratch and win ticket, and I want, or I saved it. Let's say, maybe that's even better. And I want to have $10,000 in 6 years. What do I put away today? So now I'm looking for P. So P is this equation here. Okay, so just be careful. Use this equation, and then after that, after you've modified, you just go ahead and you go 1 plus, and up to you if you want to go to 4 decimals or use it as a fraction here, and do this and do this. Okay, now the answer, your answer will be, let me just see what the answer is here off the top of my head. Let me just do this in my head real quick. I don't even have the answers here. My answer off the top of my head is $7,412.80, I think. I'm just guessing. I forgot to. Oh yes, that is correct. Okay, so 7,412.80. Now let's be careful. Let's look at this and see if it makes sense. This is less than this. Okay, so the question is, how much money do you have to put away now so you have $10,000 later? Well, it better be less. than later, okay? Because we live in a society where your interest grows, right? So I'm putting away this amount now to get more later. So if this answer was 13,000, something like that, what you probably did was you messed up the equation and used the wrong equation or forgot to divide. Okay, that's it for compound interest. Good questions, very valid, but limited because you don't have the regular investments. So when you do later on, we'll look at a couple of different questions where you're putting money in per month and how much money do you have later, or you on the other side, you may have a loan and you have to pay it off per month or every 2 weeks. How much money do you have to pay per payment, or how long does it take you to pay off the money for your car, etc. Okay, those are the questions that are coming up. And I hope this made sense. And take care.